For our next unit, we're going to step back into coordinate geometry. So before we get into our new unit and how we're going to use coordinate geometry, I want to review 3 of the formulas that we talked about in coordinate geometry, because we're going to need to know those and know how to use those for this unit. So let's take a look at our notes for today. Remember, you can always print these out to make it easy for you. So the 3 things we're going to discuss today are slope, midpoint, and distance. So let's talk about what the slope is. Slope is just a measurement of steepness. Okay? And you know slope a couple different ways. First of all, M is slope. We know it can be rise over run. And then we learned a formula. Well, we learned a formula for that we'll talk about in a little bit. But that's the main idea of slope. Okay, it tells me steepness, and we learned about how that steepness can work. Midpoint is another thing. Midpoint is the middle point on a segment. And we've done a lot of stuff with midpoint. We've had a formula for that as well, so we're going to look at that formula. And then distance. Distance tells me the length of a segment. Whoops, can't spell segment. Okay, so steepness, point on the middle, and length. Those are the things that we're going to look at. So let's start with our first one, slope. So we had a formula for slope that said if you had 2 points, x1, y1, and x2, y2, we can calculate that with y2 minus y1 over x2 minus x1. Okay, the change of the y's over the change in the x's. And that's a basic formula for slope. This is something you're going to want to memorize. Okay, if you don't already know it, learn it. So we got a problem, like I want to find the slope between points A and E. So there's some sort of line or segment, let me draw in a segment here, that goes from A to E. And we want to find the slope or the steepness of that segment. So to do that, I'm going to go to my slope formula. Well, let's get our points. A is at the point -3, 1. And E is what we're looking at, is at the point +2, -5. Okay? So now we're going to calculate that slope. Remember, y2 minus y1 over x2 minus x1. What some people like to do, they actually like to come in here and call this x1, y1, x2, y2. Some people do that because it helps them remember what goes where. So I've got 5 minus 1, 2, minus a -3. Be careful of that. Okay? Minus the negative leads me to the plus. So that gives me a 4 over 5, and there is my slope, 4/5. Okay? So some facts about the slope. Slopes of vertical lines. Tell me what you know about slopes of vertical lines. Hopefully you said that the slope of a vertical line is undefined. Okay? Sometimes I'll write that as M equals null set. We don't have a slope for vertical lines. Tell me what you know about slopes of horizontal lines. Focus a little bit. Slopes of horizontal lines are 0. So M equals 0. Okay? Parallel lines. Tell me what you know about slopes of parallel lines. Good. Hopefully you said slopes are equal or congruent. Okay? Parallel lines have the same slope. What about perpendicular lines? Okay, slopes are opposite reciprocals. Okay, and we talked a lot about that in our circles unit as well. So that's basically, in a nutshell, what we're going to need to know about slopes. So let's look at the other thing, one of the other things we have to talk about. Midpoint. Now, midpoint is just a point in the middle. And if we've got 2 points, then I can find my midpoint, usually noted as a capital M, by basically averaging the points. So x1 plus x2 over 2 and y1 plus y2 over 2. That'll give me my midpoint. Notice I put it in parentheses with a comma in between because this is a point. Okay? Notice that this is the one that we do addition on. People make that mistake a lot. So let's take our same segment that we were working with, segment AE. We already found the slope of that segment. Let's find the midpoint of that segment. So the midpoint of that segment, let's see, get my points again. A is at negative 3, 1. E was at 2. Did I forget a negative in that last problem? I did. Okay, so you're going to correct that last problem, negative 5. Okay, so we did make a mistake over here. This should have been a negative 5, which gives me a negative 5 here, which actually makes that a negative 6 over 5. So watch out for mistakes like that. It's easy to miss that negative. So back to this, my midpoint now. My midpoint will be, I'm adding now, negative 3. In fact, you know what? Let's write out the formula. It's always a good idea to write your formulas because then you're going to start to remember them. So the midpoint is negative 3 plus 2 over 2, and 1 plus a negative is negative 5. So that's going to give me a negative 1 over 2, and this will give me a negative 4 over 2, and I'm going to simplify that if I can. Negative 1/2, negative 2, and there's my midpoint. In fact, we could even graph that. Negative 1/2 down 2 puts the midpoint right about there. And it's neat when you can put it on a graph because, you know, yeah, that looks like it's about the middle. So good. So a couple facts about midpoint. Tell you what, see if you can fill in these blanks yourself. Go for it. Okay, if two segments have the same midpoint, then they bisect each other. The center of the circle is the midpoint of the diameter. And if a line intersects a segment at its midpoint, then the line bisects the segment. So we can actually use midpoints to find bisectors or to show something as a bisector. Okay? All right. One more thing to talk about, and then I'm going to let you try some problems. The last thing is the distance formula. And we've seen the distance formula quite a bit. We talked about it when we talked about circles and the radius. So the distance formula, remember, was just a fancy version of Pythagorean theorem. So big square root, and we did x2 minus x1 squared plus y2 minus y1 squared. Okay? So that's going to give me my distance whenever I have 2 points. So let's find the distance of AE. Okay? What is the length of segment AE? So again, let's get our points, and this time I'm going to make sure I do it right. Negative 3, 1, and E is at 2, negative 5. So my distance now, I'll use capital, or I'll use D for distance. So x2 minus x1 squared, y2 minus y1 squared. So that's going to be 2 minus negative 3. And then negative 5 minus 1. Do what's in parentheses first, okay? You can't just take away the squares under the square root. So 2 plus 3 is 5 squared. Negative 5 minus 1 is negative 6 squared. So that's 25 and 36. That's going to give me 61. And I don't think 61 breaks down at all. So there is our distance, the square root of 61. Don't be surprised. If this can simplify, always simplify it. So a couple things about the distance formula. Fill in these blanks the best you can. If two segments have the same distance, then the segments are congruent. The radius of the circle is the distance between, and you could switch the order of this, the center and a point on the circle. And another word for distance could be length. Okay? So there you go. We've got 3 things to look at. Slope, midpoint, and distance. Go ahead and try 3 problems. You're going to do these. and then I'm going to show you the answers. Okay? Go. So the slope, using the same points here, so 8 minus 1, that's the difference in y's. 6 minus negative 8, so that's 7 over 14, slope of 1/2. Not too bad. Midpoint between those. Midpoint, I'm adding them this time, so negative 8 plus 6 over 2, 1 plus 8 over 2. When I add those together, that's going to give me negative 2 over 2 and 9 over 2. So my midpoint is negative 1, 9 over 2. And the last point, distance. Put my big square root in. So negative 8 minus 6 squared plus 1 minus 8 squared. Negative 8 minus 6, ooh, big number there. That's going to be 14, I believe. So negative 14 squared, negative 7 squared. Negative 14 squared, I got it in my calculator to get that one. Oh, 196, I should have known that. Plus 49. Remember, when you square negatives, they always become positive. 245. And let's see if we can break that down. That actually does break down as 49 and 5. So, whoops, fell off the list there. 7 square root of 5. Okay? And if you wrote in there 7 square root 5 or 7 radical 5, I'll understand that. Excellent. Remember these? We're going to need them tomorrow. So I will see you back in class.